We're here to show you a video on how to fix sealed batteries. Sealed batteries are different from regular open flooded batteries, and the way to identify a sealed battery, which have many names such as gel, VRLA, SLA, they're all types of names, but generally we'll show you a way how to easily identify the battery so you know exactly how to identify what is a sealed battery and exactly how to fix it. So these are a small selection of sealed batteries here. If you dissect this battery, it looks like this. All the electrodes are separated by glass mat fibers, and these glass mat fibers basically absorb the acid inside the battery. So there's no actual physical liquid inside the battery. If you push the battery over, there's no liquid coming out. Sealed batteries have no physical liquid coming in or out. That's generally how they are. Well, just a little bit, but you usually don't see much at all. As compared to the open batteries, this is an open forklift battery, and they're flooded, which means they have actual physical liquid inside. I don't know if you can see that. There's physical liquid in there. And the inside of this battery would look like this. There are no absorbing fiber between the electrodes. So this is obviously an open type, and open types have lots of liquid in it, like so.
Okay.
Usually open types are more easily accessible with like a simple cap you can screw open, or as with the car battery, they're really easy to remove. Anyways, he's just showing you that there's a lot more liquid acid inside the battery. So that's an open battery. Those are the differences, and they should be pretty easily to identify because you won't see any sloshing liquid inside. This right here is they're open batteries. These are not sealed batteries, and if you shake it, see, you can see actual physical liquid moving in. This is an open truck battery, so make sure you're not mistaking sealed batteries for open batteries, like so. And yes, these have dangerous acid that can spill out. Oh, be careful. Yeah, that's acid coming out. That's dangerous stuff, guys. So be careful and wear definitely protective covering when repairing batteries. This is a 12-volt sealed battery. You need to break the plastic seal, that's the vent top, and remove each of the caps like so. And that's how you basically access it. Sometimes they seem inaccessible, but they are quite easily accessed with a little elbow grease. Anyways, now he has access to all 12 cells of the sealed battery. The difference between these batteries, this one, and this one, and this one, and this one, is that this is a 12-volt battery. It has 6 holes. Each hole represents 2 volts. This battery is a 2-volt battery, and it only has one accessible hole. That means it's a 2-volt battery. Let's just say for sake of simplicity, yeah, there we go. See, there's no liquid coming out of that one. Shows that it's a sealed battery. Much different from the open batteries. So once you've identified the batteries, identified the voltage, what you want to identify is the amp hours. Oh, here's another battery. I'm sorry. This one was sealed by a glue seal, and with a little elbow grease. It's quite easy to take off. And usually the sealed batteries are covered by these little rubber caps. And the cells are accessible by those holes, as you can see right there. Also, there's no apparent liquid coming out of the battery, so you know this is a sealed battery. You can open it with a driver as so. Usually they're sealed, unlike open batteries. And sometimes the caps are accessible and easily, sometimes they're not. And usually they're covered with a vent valve that has a little cap over them that could be easily removed with any simple tools. Now there's a cap right there. Next, let's identify, usually on the battery itself, you'll find the voltage and amp hours. As you can see here, this is a 12 volt, 88 amp hour battery. Basically, you know the amount to add to each battery by taking 10% of the amp hours. So in this battery, you're going to need about 10 milliliters of additive for each cell. 10 liters of additive for sealed batteries cannot be added by itself. You need to mix this 10 milliliters with distilled water, generally 4 times the amount than the additive. So if you're going to have, let's just say for sake of simplicity, this is a 100 amp hour battery. You're going to need 10% of that, which is additive, which is 10 milliliters, times 40 milliliters of distilled water, which is 4 times the additive amount. You're going to take that 10 milliliters of additive and 40 milliliters of distilled water, mix it well together, and add each into each cell. So if this was a 100 amp hour battery, you would be adding precisely 50 milliliters of additive mixed with distilled water into each cell. And 50 times 6 is a total of 300 milliliters per battery. Anyways, once you establish the battery is sealed or open, and you establish the amount of additive and distilled water to add to each cell, you want to be charging at no higher than C10 rates. C10, C stands for charging, 10 stands for 10 hours. So for example, if this battery here were a 100 amp hour battery, it would take 10 amps to charge it to full capacity within 10 hours. That's what we mean by C10 rates. If it were a C5 rate, there's generally C5, C10, and C20 rates. Most batteries go by C10 rates. So 10 means the amount of hours it would take to charge that battery to full capacity. So you generally don't want to charge these batteries higher than 10% of its rated capacity. So once you've added the additive, you want to hook up your battery to the charger, like so, and charge it again at no higher than C10 ratings. So once you have your battery hooked up to your charger, you charge it well, for at least 10 hours or so till the battery is fully charged. And we recommend to actually fully discharge it once as well to complete the desulfation process. Once you've charged it and discharged it a full cycle, you should charge it again. And your battery capacity, if you're checking it before and after the charge, you'll see has probably returned to close to normal capacity of the battery as if it were new. So generally that's our method for charging up and fixing sealed batteries. Generally you only need to do 1 cycle of charging and discharging, sometimes 2. If you have a good battery charger, it can hook up a bunch of batteries in a series and actually tell the capacity, read the capacity for each battery, so you know it's actually improved. Charging the battery one at a time is not really economical. So if you were to charge a bunch of them in a series, like you would see in a telecommunication tower, then that would be more effective. Here's another battery charger. If you're charging one at a time or not, a charger that can vary its amperage, as you can see, this can go from 1 to 15 amps, is very important because you don't want to overheat and overcharge the battery, nor do you want to undercharge it. You want to give it the right amount of charge. And it's really important because if you do overcharge these batteries, unlike open, it can get warm and it's fine. You're not going to have much damage to the battery. even if it's a bit overcharged. But with the sealed batteries, they're much more sensitive to overcharging or overheating. So if you really don't want your battery to reach higher than say 40 degrees, if it gets much higher than that, the heat is gonna rise exponentially, and very easily it'll damage or break the battery. So definitely much more care needs to be taken when repairing sealed batteries as opposed to open batteries, and that's the big difference. So if you have any more questions regarding this process of repairing the sealed batteries, feel free to contact us, and we'll be happy to answer any questions you might have. Thank you, and have a nice day.